While road assets are being maintained, the succeeding activity in the sustainable road asset management cycle is known as performance monitoring, which identifies level of service. Level of service is the output road agencies or road users expect from the organization in describing what the organization intends to deliver. It is commonly related to service attributes, for example, quality, reliability, responsiveness, sustainability, timeliness, cost, and accessibility. The level of service could also be related to product specifications or design standards in the prevailing industry. The performance monitoring process in a sustainable road asset management involves measurement of specific indicators to identify the current level of service of assets and its capability. If a deficiency in level of service is recognized compared with the desirable level of service, interventions would be required to bridge the gap. This process is predominantly applicable to road assets, for example, road pavement, traffic signage, and road marking. These assets have lifespan and are subject to deterioration due to aging, traffic loading, climatic and environmental factors. Road pavement is one of the examples of road asset which will deteriorate in time under traffic loading and climate. One of the most common pavement condition indicators perceivable by road users is known as roughness, expressed in the International Roughness Index, IRI. New constructed asphalt pavement generally gives low IRI values, which indicate a good riding quality. However, as aging process continues and under change in traffic conditions, the roughness of the pavement increases, reflecting a decline in riding quality. As a complement to level of service, it is crucial that the asset performance and capabilities are assessed accurately to deliver the desirable requirements. These measurements are achievable by using specialized equipment to measure current performance of assets. The Network Survey Vehicle is a state-of-the-art equipment invented for network and project-level survey. It is a high-speed semi-automated vehicle equipped with digital laser profiling system, digital imaging system, road geometry and mapping system, capable of carrying out pavement surface condition assessment and GIS mapping. The digital laser profiler is capable of capturing pavement surface profile data, such as roughness, rut depth, texture, and other indices. Mounted on the rack of the survey vehicle are digital asset cameras, precisely positioned to capture asset view and pavement surface distress. The vehicle also contains Gypsy Track Geometry device, which gives road geometry data for generation of road mapping. The Falling Weight Deflectometer, FWD, is another essential equipment used to carry out non-destructive tests to assess pavement strength adequacy. On road safety aspect, the grip tester is a continuous friction measurement equipment used to evaluate skid resistance of pavements. Other handier device used for testing localized skid resistance is the British pendulum tester. Retroreflectivity of traffic signage and road marking are measured by the retroreflectometers, whereas road marking thickness is verified by the digital marking gauge. These data are then analyzed to identify the most appropriate solution, in a timely manner, to close the gap between the current and desirable level of service. The processing tools which utilize these data are the Road Asset Management System, Pavement Management System, Life Cycle Cost Analysis Tool, and other modeling tools. One of the greatest benefits provided by these tools is to forecast future intervention needs to meet the long-term level of service within the available resources. In a typical pavement asset management system, the system database contains pavement inventory, condition, structure, traffic, and work history data. These data can be imported to a decision support tool to perform strategy, program, or project analysis. The output is the establishment of policies, optimized multi-year works program, funding requirements, and network performance predictions. Gamma Light Group has excellent achievement in providing the performance monitoring service to our valued customers. One of the major successful services we have provided to the Ministry of Works Malaysia involves data collection for digital road data sets and other related features. We have also supplied performance verification, in supplying traffic signs and road markings for road authorities to ensure standard and specification compliance and to provide justification for renewal scheme. The Brunei Pavement Management System is a project involving the upgrade of previous system with improved functionalities and extensive pavement condition surveys on the road network. These surveys were carried out by our specialized and advanced equipment, the Network Survey Vehicle, FWD, and Grip Tester. Upon verification of the most effective solution to raise the current level of service, the performance monitoring then leads to the design and planning stage in the overall sustainable road asset management cycle, where options and candidate assets for treatment or rejuvenation are investigated in greater detail prior to actual implementation.